Information Systems Security Engineering Professional, often shortened to ISSEP, is an advanced ISC² certification for cybersecurity professionals who want to design security into systems before those systems go live. This certification is about building security into projects, applications, business processes, and operational environments from the beginning. In this Monday certified feature from Bare Metal Cyber Magazine, we are looking at what the credential is, who it is really for, what the exam tests, and how it fits into a larger cybersecurity career path. If this certification is on your study list, a free and complete audio course is available in the Bare Metal Cyber Academy at baremetalcyber.com, complete with a study guide and a second ebook featuring 1,000 flashcard questions. ISSEP is not usually the first certification a new cybersecurity learner should chase. It is better understood as an advanced goal for people who already have experience with cybersecurity, systems engineering, information assurance, security architecture, risk management, or regulated technology programs. That said, early career professionals can still learn a lot from it because it shows where security work can grow after foundational skills begin to connect. It points towards a version of cybersecurity that is not only about monitoring alerts or responding to incidents, but also about designing systems that can operate securely over time.
The certification sits in the security engineering lane. It focuses on requirements, risk, secure design, implementation, validation, operations, change management, and disposal. In plain English, that means the exam expects you to understand how security fits across the full life of a system. Security is not treated as a final checklist at the end of a project. It is treated as something that should influence how the system is planned, built, tested, approved, operated, changed, and eventually retired. This makes the credential especially relevant for professionals who work in complex environments. That may include government, defense, critical infrastructure, large enterprises, cloud programs, regulated industries, and mission-focused systems. In these environments, security decisions often affect business operations, mission outcomes, legal obligations, vendor relationships, technical design, budget, and risk acceptance. ISSEP is for people who need to think across those lines. ISC² is one of the most recognized cybersecurity certification organizations in the industry. Its credentials are often associated with professional experience, ethical expectations, continuing education, and vendor-neutral security knowledge. That matters because this certification is not tied to one product, one cloud platform, or one toolset. It is focused on security engineering principles that can be applied across many types of systems and organizations. The credential also fits into the broader ISC² professional ecosystem. CISSP is the broader cybersecurity leadership and management credential that many professionals know best. ISSEP adds specialized depth in security engineering. It sits near other advanced concentration-style credentials, such as ISSAP for security architecture and ISSMP for security management. The security engineering focus is what makes this one distinct. The exam is built around 5 major areas. First, Systems Security Engineering Foundations. Second, Risk Management. Third, Security Planning and Engineering. Fourth, Systems Security Implementation, Verification, and Validation. Fifth, Secure Operations, Change Management, and Disposal. Those areas sound formal, but the idea behind them is practical. The exam wants to know whether you can connect security decisions to the actual life cycle of a system. A strong candidate understands how security requirements are created and traced. They understand how risk is identified, analyzed, communicated, and managed. They understand how secure design choices are made and how those choices affect implementation. They also understand that testing, validation, authorization, configuration control, operations, and disposal are not separate from security engineering. They are part of the work. This is why ISSEP is not just a memorization exam. Definitions matter, but definitions are not enough. The exam rewards applied judgment. A question may describe a system with mission requirements, operational constraints, supplier dependencies, budget pressure, inherited controls, regulatory expectations, and changing technology assumptions. The best answer may not be the one that sounds most technically aggressive. It may be the one that best fits the lifecycle stage, the risk context, and the engineering objective.
One common misconception is that this certification is simply a more technical version of CISSP. That is not quite right. CISSP is broad. It covers a wide range of cybersecurity leadership and professional knowledge. ISSEP is narrower and deeper in a specific direction. It is about security engineering practice. It asks how systems are designed, implemented, assessed, authorized, operated, changed, and retired.
Another misconception is that security engineering only means writing secure code or selecting security tools. Those things can matter, but the credential goes much wider than that. Security engineering includes stakeholder needs, system requirements, risk decisions, architecture constraints, procurement, supplier considerations, verification evidence, configuration control, operational sustainment, and end-of-life decisions. It is a discipline that connects technical detail with lifecycle accountability.
The exam is typically a 3-hour test with 125 items. Candidates should expect multiple choice questions and advanced item types. The passing standard is commonly reported as a scaled score of 700 out of 1,000. Because this is a professional-level exam, preparation should focus on understanding and application, not just last-minute memorization.
A good preparation plan starts with the official exam outline. Read the outline once to understand the shape of the exam. Then read it again to identify weak areas. Many candidates will discover that their weak areas are not always the most technical ones. They may be weaker in lifecycle planning, acquisition, validation, configuration management, disposal, or the connection between risk management and engineering evidence. From there, study in phases. First, build the map of the domains. Then, focus on systems security engineering concepts before diving into small details. After that, connect risk management to design, implementation, validation, and operations. Once the big ideas are clear, practice scenario questions that force you to choose the best answer in context. When you miss a question, do not only memorize the correct answer, ask why that answer is best and why the other choices are incomplete. Professional reflection is also useful for this exam. Think about real systems you have supported. How were requirements gathered? Who owned the risk decisions? How were controls selected and traced? What evidence showed that security requirements were actually implemented? How were changes reviewed after deployment? What happened when a vendor, cloud service, mission need, or technical constraint changed the risk picture? These questions help turn study material into practical reasoning. The Bare Metal Cyber Academy can support that study process in a flexible way. The free audio course developed by Bare Metal Cyber can reinforce the major ideas during commutes, workouts, or review sessions. The study guide can provide a more structured reading path when you need depth. The flashcards ebook can help with repetition of terms, domain concepts, and decision points. For busy professionals, using audio, reading, and quick review together can make the preparation process easier to sustain. Time management should be part of your practice from the beginning. Advanced exams can punish overthinking. Some questions may include several answers that sound reasonable at first. Your job is to find the answer that best fits the role, the system lifecycle stage, the risk context, and the engineering goal. Practicing under timed conditions helps you learn when to slow down and when to move forward. Weak areas should be handled deliberately. If you are strong in operations but weaker in engineering process, spend more time on requirements, design assurance, validation, and lifecycle topics. If you are strong in governance but weaker in implementation, focus on how controls, architecture decisions, and verification evidence connect. If you are strong technically, but less comfortable with procurement or documentation, study how security requirements flow into acquisition, supplier review, contracts, and ongoing risk decisions. Confidence for this certification comes from integration. You want to be able to explain how security engineering supports risk management, how risk informs design, how design informs implementation, how implementation is verified, and how operations preserve the security posture over time. When those pieces start to connect, the exam becomes less about memorizing 5 domains and more about thinking like a security engineer. From a career perspective, ISSEP supports roles where security must be designed into complex systems rather than inspected after deployment. It can be useful for security engineers, systems engineers with security responsibilities, information assurance systems engineers, risk and authorization professionals, secure acquisition support professionals, and technical leaders in mission-focused environments. It can also help people who work between technical teams, program offices, business leaders, and risk owners. Hiring managers may view the credential as evidence of advanced, specialized security engineering knowledge. It does not replace real experience, and it should not be treated as a shortcut into senior engineering work. Its value is strongest when it confirms the kind of work a candidate has already done, or when it clearly supports the direction that candidate is moving. The credential says that you are thinking beyond isolated controls and towards secure systems across time. For many professionals, the path toward this certification may start with broader or more foundational credentials. Security Plus, Network Plus, SSCP, or CISSP may come earlier, depending on the person's background. After that, ISSEP can make sense when the career direction becomes more focused on security engineering, systems assurance, secure design, and lifecycle risk. If your focus is security architecture, ISSAP may be a better fit. If your focus is security leadership and program management, ISSMP may be more aligned. If your work is centered on cloud security, CCSP or vendor cloud security credentials may be more practical. The best reason to pursue ISSEP is not simply to add another credential to your resume. The best reason is that your work or your target work requires security engineering judgment. You want to understand how secure systems are planned, built, validated, operated, changed, and retired. You want to think about security before a system fails, before an audit finding appears, before an incident exposes a design weakness, and before operational teams are left carrying risk that should have been addressed earlier. For early career professionals, this certification can still be valuable as a long-term roadmap. You may not be ready for it yet, and that is fine. Studying what it covers can show you which experiences to seek. Look for chances to participate in system design conversations, risk assessments, control implementation, security testing, documentation reviews, change boards, cloud architecture discussions, and project planning. Those experiences will make the certification more meaningful if you pursue it later. ISSEP is best for experienced professionals who want to demonstrate advanced security engineering judgment across the full system lifecycle. It is not usually the first stop for a new cybersecurity learner, but it is an excellent long-term target for people who want to design security into systems instead of reacting after the fact. If your career is moving towards systems engineering, information assurance, secure design, risk-informed implementation, or mission-focused security work, this credential deserves attention. And when you are ready to study, the Bare Metal Cyber Academy resources can give you a structured and flexible way to keep moving.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.